Our next concept or our next chapter is going to be from ratios and proportions. So ratios and proportions, the competence there is the learner understands ratio and proportion and uses them in a range of context. So the learning outcomes: apply equivalent ratios, apply direct and inverse proportional reasoning, understands and apply ratios, different scale, and so on. So from here, I specifically chose a number that combines, the ratio for number for partial variation. So you see that you can do many examples from ratios. If you want to get them in details, you can go to the playlist, then you tap it, then you scroll down, you will see more lessons in details about specifically this chapter. Okay, if we handle the question we have, it says, in your village, the cost of irrigating a farm is partially variable depending on a fixed setup fee for the irrigation system and also depending on the amount of water used. So the cost, so remember, this topic is in pattern and algebra. So in patterns and algebra, you have to define any variable you are going to use. So let me start by defining the cost as C. So let C be the cost and X be the water amount used. Okay, so they're telling us that the cost is partially constant and also partially varies as amount of water used. So this K is the fixed cost for the setup fee. Then this one is they're telling us that the cost is offered in the amount of water used. So that's how we first get our equation. So if you want to see more about these equations, visit the playlist, then you go to proportions and variation, you see more of them. You see direct, indirect, joint, and so on. So they are telling us that it was observed that they irrigating a small farm using 5,000 liters of water. So when X is 5,000, the cost is 250. So we first substitute here. It's now our X. Call this one equation 1. Then they are telling us that while getting the same farm with 10,000 liters, the cost is 400. Substituting in here, this one is equation what? 2. So they want to determine the cost while irrigating the farm with the 15,000 liters of water. So what that means that we need to first get the proportional constants, proportionality constants K1 and K2 by just solving these two equations simultaneously. So we can say now, solve now. We can come here and we solve 1 and 2. So if I start with this one, the second, but I'm going to start with the right hand side. So 10. Okay. K1. K1, so this is K2. K2, so this is K2, not K, not X, because we are substituting it for X in there. Then this one, so then we say we use das whenever I'm solving simultaneous equations. Different signs add, same sign subtract. So they have the same signs. So I'm going to subtract. So this minus this, it goes 10,000 minus 5,000, you get 5,000. Get 2, when reduce there, you get 50. So divide by 5,000, 5,000 there. You get to clearly will be these 3 go, so that it will be 30. So putting in n to get now K1. So now my K1 plus 10,000 into 30 equals to 400,000. So this will give me 300. Take the other side. Now my K1 is 100,000. But if you put it here, BRB now 150, take the other side, you'll be getting the same value. Then after getting that, you rewrite. So now from my C equals to K1, K2X, now we rewrite. So my C will be plus now K2, which is 30, X. So now they want me to get the cost when we have, so when X is 15,000 liters, we want to get now the cost. The cost will be plus now 30 into now X, 15,000. Of course, this will give us 450 plus this, our cost will be equaling 550,000. So that will be the cost of you getting using 15 liters of water. So this is Yugi X. Now they want us also to find addition. They actually has to know how many liters of water they can use if they have a budget of 1,500,000. So they're giving us now the cost of, they want to know how many liters of water they can use. Still, we just got our equation. So our C put it here. Oh my God. Okay. The figure won't figure well. So take this side, you get 1,400,000 equals to 30x. Divided that side. You see, first of all, that goes. So my 1 now 40 divided by 3 will give me the x. So this was what I was scared of. Anyway, so we shall be having 6.7 liters equaling to x. So they will use 400. So you always reply to the question, to the task. They will use liters on a budget, budget of 1.5 M. Okay, so for more about ratios, just go to the playlist and see those lessons.